For 37, the table shows the distribution by age and gender of 30.5 million people who live alone in a certain region. Use the data in the table to find the probability that a randomly selected person living in the region is in the 25 to 34 age group. Notice on this table, they have given us some totals. We have males, ages 15 to 24, 0.7. Ages 25 to 34, 2.6. 35 to 44, 2.5, and so on. So we have the males, we have the females. At the end here, they gave the total number of males. They gave the total number of females. They have added these two together and got the total number of people, 30.5. And in the age group, they've given us some totals. So the total number between age 15 to 24 is 1.6. 25 to 34 is 4.3. So this one has totals built into it. Not all the charts have that. Let me go back and read it again. Find the probability that a randomly selected person living in the region is in the 25 to 34 age range. So I need the total in that age range, which is 4.3. I'll take 4.3 divided by 30.5. And as I write that, I glance at the directions, type an integer or a decimal, rounded to the nearest hundredth. If the computer says round it to the nearest hundredth, well, you need to round it to the nearest hundredth. Look at that decimal I got. I got 0.140983607. If you round it to 3 decimal places, you're going to count it wrong, even though you've given a more accurate answer. The nearest hundredth, that is 2 decimals. 2 places after the decimal. So 0.14, I looked behind the 4, I saw a 0. If it's less than 5, just drop it off. If it's 5 or bigger, you bump up the last digit that they're asking for. Let's go to 38. The table shows the number expressed in millions of citizens who moved in 2004, categorized by where they moved and whether they were an owner or a renter. Find the probability, expressed as a decimal, rounded to the nearest hundredth, that a randomly selected citizen who moved in 2004 was a renter. I don't have the totals on this one. So I'm going to need, like on that last chart, I'm going to extend this a little bit. I'm not going to write every number. I'm going to need the number in the bottom. That's the total number of people. That will be my denominator. 11.8 plus 2.7 plus 0.3 plus 18.8 plus 4.4 plus 1, 39. Let's see, what did they ask for? That a randomly selected citizen who moved was a renter. So I will need the total for the renters. I'll put it right here. 18.8 plus 4.4 plus 1, 24.2. The probability the person was a renter would be 24.2 divided by 39. 24.2 divided by 39 is 0.620512821. Round to the nearest hundred, 0.62. Number 39. The table shows the educational attainment of a country's population, age 25 and over. Use the data in the table expressed in millions to find the probability that a randomly selected citizen, age 25 or over, was a man with 4 years of college or more. This table, we have the totals. The 174 will be the denominator, the total number of people. A man with 4 years of college or more. So that's luckily that's its own column. 24, it's in millions, 24 million men. If you just say 24, that works. 24 divided by 170, oh, that's a 4. I wrote the wrong number. 24 divided by 174. 24 divided by 174 is 0.13793 and a few other digits. Oh, they want a fraction this time. So I fell into a trap. I kind of got used to doing decimals, and then I read, wait a minute, fraction. 24 over 174, let me use my fraction key. 24, the fraction key is this A, B over C. 174, press equals 4 over 29. Problem 40. Determine whether the statement makes sense or does not make sense and explain your reasoning. When I toss a coin, the probability of getting heads or tails is 1, but the probability of getting heads and tails is 0. This one is kind of a little play on words. It kind of goes back to that spinner problem, yellow and green. When you toss a coin, what's the probability of getting heads or tails? It's 100%. That's going to happen. Toss a coin, I will get one of those too. What about the probability of getting heads and tails on one coin toss? That's 0. This statement makes sense. Let me look at the choices where it says makes sense. I'm not going to pick A because it says it does not make sense. I'm not going to pick C. Part B, the statement makes sense because when you toss a coin, you can either get head and tail at the same time? No. Part D, the statement makes sense because when you toss a coin, you can either get a head or a tail at a time. You cannot get head and tail both at the same time. That's the one.